Now let's see if we can do the last problem on the practice final. It's a sum question. We just have to compute this sum or find a closed value for this sum. And so this is important for calculus because we're getting into Riemann sums and the Riemann integral, so we need to be able to evaluate these sums, and you'll see sums again at some point in calculus 2 when you start to study series. So let's do it. We're going to use some of the nice properties of the sigma notation, which I'll point out as we get to them. So how do you start working on this? You might ask yourself, does sigma do anything nice with the square? And the answer is no. So I'm going to just, out of total desperation, I'm going to multiply out this binomial and see what happens. So I've got sigma I equals 1 to n of 3 squared, which is 9, plus what happens here? I get 6 of these, right? And then 2 of those, so 12 times I, and now I've got plus 4I squared. Okay, so now we see that things are very nice, right? Because sigma does do nice things with other little pluses. So sigma of something plus something is just sigma of something plus sigma of something. So we can bring in the big sigma. What I mean is that this stuff is the same thing as sigma 9 plus sigma 12I plus sigma 4I squared. Okay, and I guess I can go back and put the little counters down here. I equals 1 to n. I equals 1 to n. Okay, but that's not all, right? Sigma is even nicer. Let's just look at this first thing. This is just 9 added to itself n times. So this first part is just 9n. Okay, and what about this next thing? Well, the 12 comes out for one thing. So 12 is in common to everything in this sum. I can factor it out, and so that gives me 12 times the sum, and the only thing left inside is the little counter variable I. For this last thing, 4 can come out the same way. So I equals 1 to n. And the only thing left now is I squared. And I'm in good shape because these last two things that I have left, here's I, but I have this nice formula for what that is, closed form formula. And here's I squared, but I have a nice closed form formula for that too. So really now all I have to do at this point is plug those things in and I'll be done. So now I have 9n plus 12. This becomes n times n plus 1 over 2. And I've got plus 4. And this becomes n times n plus 1 times 2n plus 1 over 6. And that is the answer. You could cancel these, but who cares? So done.